Hi, I'm Tom Cherryums of the FujiNet project. We're continuing our videos here on developing software for ColecoVision and Atom. And this next video is kind of just an exploration video. Now that we've got a set of tools set up and that we've proven that we can build things with them, well, how do we start? How does one start to figure out what is possible and start making the first small steps to doing useful things? Well, this video is going to be more about technique than procedure. So basically, we're going to be bouncing around the system, looking at various files, showing where things are, and pointing out books, references, and things that you can use in order to start getting a grasp on things before I actually start dealing into more elementary topics on the language and how things are actually set up. Because that's how we learn, especially when we were younger, right? We basically saw a piece of code and started tinkering with it, seeing what happens if we changed one little thing, changed another little thing, and observed those results. And if you carry that methodology with you forward, you can actually get a lot done in a very short period of time. And I'm going to try to see if I can help kickstart that process. So we have here our development desktop as before. We just got done installing Convert 9918 here. And we've got our text editor, which if we open it up, it's still got our little hello world sitting right here, ready to go. And we've got our little terminal window, which we'll use to take and build things as we need to. Our file viewer that works as if we need to. I'm going to go ahead and turn off Show Hidden Files here to make it a little nicer. We've got our little home directory here. So let's see. Let's start messing with our Hello World program first here. Well, we know we can definitely change. What's inside of here. This looks like text we can change. It's in English, and it's surrounded by this printf thing right here, and we've got this while thing here that we added in so that it sticks here on the screen. We have other words that we can recognize here, like main, and maybe you know what void is, which means nothing. I'll explain what that is later. Some things like include, and so we're obviously including something. This you might recognize this as a file, stdio.h. Well, this is a file you can actually look at and see what's inside of it. There are functions inside of this file that you can use, for example, and so on. So, I mean, let's start by changing this text a little bit. Hello, everyone. Sure, why not? We'll take it and we'll save it. And you'll see there are shortcuts here. You might want to get used to using the shortcuts for Control S to take and save your file. Okay, great. It's now saved. We can go into the workspace area here that we've created for ourselves. Go into Hello. And we can see the bits and pieces here. We can right click. We can open a terminal to this area right here. And try to pick up as I'm typing things in the terminal. This is how you do things inside the terminal here. For example, you can do ls to display a directory. A good command line Linux tutorial is very beneficial here because it will show you the various things that you can do inside the terminal to see all these different things. Well, by the same token, you can use something like cat to display hello here as well. And since we're sitting inside of Ubuntu, which is Ubuntu is based on Debian, you could even use a text editor inside this window to take and edit hello world, hello.c. And now it's inside of, now you can edit it inside of Pico or Nano if you wish. So you can see here, editor, you can see commands, Control X to exit, Control K to cut, etc. So we'll go ahead and just exit. Hold down Control, hit X. We're back out again. Okay. So we're starting to get our feet a little bit. Of course, you can, the terminal window also has the ability to have manual pages. So you can have documentation that you can read very quickly. So let's say man editor. So since editor is set to nano, it literally went, okay, well now we have the manual page for nano and how nano works. All the options you can pass from the command line, various different bits of information, even a web page, so you can go to it. You can control click on that and go to that page if you wish, and so on. Okay, we can see H for help or Q to quit. Sure, Q to quit. Bam. So we're floating around in here. Now, you saw me before use the command ZCC to start the compiler. This is the compiler front end, and its job is to take and call whatever is necessary to compile this file, the source code in this file, and produce something of output, the output that you request. And if we zoom in a little bit here, I just zoomed in so we could see here. There are all sorts of options that you can set here. The ones that we've already used are O to specify the output or object file, and that's what ultimately gets created that you can use. And we also used create app, which uses the app make program to take that binary that the compiler produces and wrap it into a cartridge image or wrap it into a data pack so that it can be run either on an emulator or copied to a disk emulator to run on the real hardware. There are other things as well, but those two are enough to get us by for now. But there are other things, all sorts of other options that you can use, and it pays to actually take an experiment with them to see what all can be done here. And as you gain proficiency, you'll start to use more of these options. And in point of fact, you're actually going to be using, you're typically not going to be using, as your projects get bigger, you're not going to be using ZCC directly, but you're going to be using a tool like Make to, to do these things more directly. But we'll cover that later. For now, if we recall what we've done, we made a change up here, we saved it, and now we're going to take and compile it again. Recall that we did ZCC, and we have to specify, because the commands literally say that the first thing that we have to specify is a target that begins with a plus here. So we have to specify plus Coleco, and we need to, at the very least, if we just specify hello.c here, what will happen is it will create a file called, it'll create a bin, a BSS bin, a data bin. Why did that happen? Well, we didn't specify an output name, and compilers traditionally, when they're not presented with an output name, they'll just say, oh, we'll call it A, because we have to call it something. But this in and of itself is not runnable. You'll notice a few things that are rather interesting compared to the ROM that we have here. It's a bin file. This is a direct binary output from the compiler. It's only 3.7 kilobytes long. And you'll notice that the ROMs, for example, for Coleco are 32K long. See. So we have to take and make sure that when we take and build things, we have to build them in the right form. So let's go ahead and just delete that. We'll take and delete it, right click and move to trash. Just put it there. And we'll go ahead and remove these intermediate files too as well. So we have hello, and we'll go ahead and remove these as well. Just start off with our basic RC file. Bam. Put that to the side for just a moment, and we'll try again. ZCC, and now here's a trick. If you want to run the last command that you just ran, you can use the up arrow to do a command history. And it doesn't just keep the last command, it actually keeps a running history of the commands that you've typed in this window, which can be very helpful. So we start, let's do this again. We'll up arrow here. And we'll add a few things. We can back and we can insert things into this here. So we'll start with create app. Remember the create application option from earlier, which is run app make so that we can create something that can be emulator usable. Very useful. And see the difference. Okay, the compiler runs here. We see the output. And now we see a ROM. It's better. We can actually run that and we can see the results here. But we forgot one option, or rather I deliberately forgot one option. And that is to specify the outputs. Let's do that again. Move to trash. Up arrow again, and this time we're going to go hello.rom, just like that. We have to specify the extender in there too. So there we go. Come back, we see hello ROM. There it is with our change. And you can keep modifying and changing things and seeing the results. Let's add another, can we add another printf line? Yeah, well, yeah, we can. And you'll notice here that as I'm typing certain things here, it's wrapping around so we can see it inside this window here, but the same behavior will actually happen in here as well. So Control S. Notice I didn't have to go there. I just did that. It's a nice little keyboard shortcut. Good to know. We saved it. And we run the command again. Okay, great. And you can see what actually happened here. Whammo, we did a little text wrapping, and actually we were very fortunate that this wrapped just enough characters that something didn't hang off the screen, off the side of the screen here. But it took and wrapped the text for us. The same behavior happens in the Atom as well. Remember that in order to build an Atom application, we do subtype equals Atom. Creates a DDP for us. And there we go. We can see both of them running here and we can compare. Oop, I did Coleco ROM, didn't I? Huh. Did I? First launch. Didn't I do that? Anyway. Sorry. When you make a file, yeah, you have to have the right extender because it will do that. Let's do that again. That was a human error on my part. We can compare the two. Bam, there we go. Bam, there we go. So you can see that we're doing these things in parallel using the same functions. We can add more printfs and we can do more, but there are still more things that we can do. Well, what more things can we do? How do we figure out where to go? Well, let's start by looking at the Z88DK website. You can see, for example, we have home, downloads, docs, screenshots, targets, forum, and source. Yes, there is a forum. So if you want to ask questions, feel free to basically ask questions. The people will respond. This is excellent. So yeah, there's lots of things that we can do here. Boom. So go to docs. and we can really start to see what's going on. Right now, we're just using the classic library here. We've basically gone through getting started, and one of the things in getting started here are that there are even alternate uses of how to call this compiler. If you're a more advanced user and you want to be able to keep this compiler in a container, for example, you can use it from Docker, you can use it from Snap. If you want to use this from CMake, you can use it from CMake, and so on. I prefer basic makefiles, but there are also a whole wealth of pages, if you take an uncollapse here, that you can look through on every subject that the compiler actually provides as you start figuring out where things are. Well, if we take, for example, and go overview, it starts by showing you, okay, this is the classic library. Here are some of the basic things that you have. You have a generic console, which we've been using, which basically provides printf and all of those functions right there. All of the things that you've got, but you've also got sound libraries to output to the sound chip, input for getting things from joysticks or keyboards, and so on. All sorts of graphics libraries, such as the monographics library and what we really want, the VDP support. Well, that looks interesting, doesn't it? Let's take a look at that. Okay, the TMS 9918 library provides support for all these targets, which means if you use these functions, your program has a high probability of being able to be built for all of these targets out of the box. So it starts by showing you the screen modes and things that are supported. There is even support for the 9938 and other things like that, different screen modes. So we've got mode 1, mode 2, mode 3, text mode, etc. So how about, let's try something here. Let's take and shift into text mode, because right now we're actually in graphics mode 2 mode by default. We can do that. And in point of fact, because you see the semicolon right here, these are actually two separate lines. They're just put on one line. C doesn't care. So C will parse the information that comes across, and it will look for these semicolons, which it interprets as the end of a particular statement. So what we've added here are basically two things. We've added a variable declaration. This is a new variable called mode. It's an integer, meaning it can hold whole numbers, and it has an initial value of 2. We then take and use a particular function called console IOCTL with this particular constant. In C, constants or values that don't change are typically in uppercase, so that we don't have to remember that this is a number like 12 or 13 or something like that, and that it expects a pointer to a variable. We'll explain what pointers are later, but suffice it to say that we want the address of where this variable actually is so that it can grab this value. Okay. We need to do one thing that's not actually here, and that's that we need to add the the support for the IOCTL function. Otherwise, the compiler may very well complain and assume, oh, well, this function actually requires an int. And actually, we'll just do this like it is right here. We'll save this, sure. And we'll recompile. And you'll see what happened here. It gave us a warning first and foremost. Implicit definition of console IOCTL. It will return an int. Prototype it explicitly if this is not what you want. And that would have been fine if it had known what this value was. It didn't. So the compiler took and bombed out and said undefined symbol. Everything in the compiler that the compiler works with is a symbol. variables are symbols, functions are symbols, expressions become symbols in their own right. Anyway, so with that said, all we really need to do, we at the very least read what we have here, and we need to add this header right here using the include directive. At the very least, it will still complain that it doesn't quite know what the return of this is supposed to be, but that's fine. It will still build. We're not using the return of that value anyway. So with that, we'll come back into the editor here, and we'll add our little include directive. Save, and try again. Okay, well, looks like I still need to add, we still need to add this IOCTL set mode here. So let me see. Let's go back. Do a little bit of digging here. And in fact, it actually may behoove us to do a little bit of digging here. And I'm doing this explicitly to show you the process by which you figure out where certain things are. Well, we know, for example, that we have a copy of Z88DK in here, and that everything in the world is sitting inside of here. We have examples, all sorts of examples that we can take and run for all sorts of different systems. Maybe something in here is useful. Maybe we can do some text searching in text here. Now files. Can we take and search text here? Will the file manager allow us to search for text? Not directly inside here. So we will take and start looking through other folders here. They include. Well, we have all sorts of includes here, including things like standard I/O, which we've seen before. If we take a little look at this, pull up a little bit, we can see all sorts of interesting things here. And we can see function definitions for things like opening files and what parameters they actually need. We can see things like put character to put a single character on the screen. Check for the end of file. And so on. So these give you an idea of what functions are actually available. And these are actually defined inside the language itself. Well, let's just take a look at scanf here, for example. We can copy that, and we can put that into our little browser here. Oh wow, that's a C library function. That's scanf. Well, it shows you. You can use it to read formatted input from standard input, which in our case is the keyboard. And what the format values are. And here are examples of using those functions that you can type in. Matter of fact, let's bring one in just because. And yes, I know I have branched off here, but this is more about technique and process than it is about closing any particular circles here. We'll take and make a new folder. I'm going to go ahead, right click here and add this to book and drag this into bookmarks. So it's just there. New folder. And this is a scanf example. Will this work? Well, we'll see. Now we can literally take and make a new file here. We'll bring hello off, make a new tab, paste our example here, because, why not? This is going to be, since this will require a keyboard, this is more for the Atom. But it's an example of how we take and find out how certain functions and certain things work. So save that. Go into workspace, scanf. There it is. We save it, we pull away, there it is. Now let's do something with it. I'm using cd ... to go up the directory, back to the workspace directory here. ls is the directory, cd scanf to go into that directory. I could just have easily have opened a terminal right here. Again, same thing. So again, ccc, plays Coleco, and this is going to be for Atom, because Atom has a keyboard. Create app o scanf.ddp. Boom. And you can see it went and built it. We were able to take that example and bring it in as is and build it, make it work. Well, let's try it out. Enter name. Okay. There you go. Entered name Thomas. Entered website http. Okay. So there you go. There's an example of taking a piece of example from somewhere else entirely, bringing it in and seeing how it works. And see what we did right there. We got some keyboard input and we did something with it. Just using the examples that we have out there. Sure, that's possible. Another possibility for what we need to do. In our case, we need to figure out now, coming back to hello, there is a particular set of functions that we know that we need. Well, IOCTL. And to find this, we actually need to do a little search here. We'll come in where, let's see, IOCTL is a console IOCTL is a function name, and we can use that as a clue. So we'll come back, go into Z88DK. And in fact, if we want to put a bookmark here, we can too as well. That might be helpful. Boop. And you can scoot them into whatever order you wish, by the way. You just drag them. Now that we've got that, we can do a search. And we will look for IOCTL. IOCTL.h looks interesting. Cons generic IOCTL, generic console IOCTL. So IOCTL, that looks important. So now we've got IOCTL and it's in sys. Okay, sys is interesting. IOCTL sys. CTL sys. Okay. We actually have something that's useful here. Generic console IOCTL, and probably what we're looking for here is IOCTL H, and this is in sys, and there's already an include path. I'll go ahead and mention that there's already an include path into these various .h directories, so that all we really need to use is the last bit of the path here. So we'll do that, see what happens. We'll try it out. Boom. So we come back out, cd ... back into hello, and try again. So now you can see that hello built without any warnings, without any issues. We had to add 2 includes here so that it knew what console IOCTL was, so that it knew what that constant was here. And we needed to add video TMS9918 so that it would have the values for these set up in place and things working as they needed to. So with that, now that we've built that out, let's go ahead, put you back to normal size there. And we can come all the way back into our workspace, go back to hello. And the rather interesting thing, what's happened here is now this is actually running in text mode. It might not look any different. It might look slightly different here, but it's running in the text mode. Let's try that again. Let's see. Oh, hello world, hello.c. Sure. Okay, great. That's good. So make sure that's good. Yep. And then we'll do subtype Atom, create hello DDP, making sure we, yep. Try this again. Boom. It's now running in text mode here. So, that's because we're in mode 2. Hold on a second. Let's try something here. Did I actually? Yeah, it's because I switched it back to the same mode. Mode 2. Okay, text. Oh, wait. Oh, that's because, yeah, okay. I switched it back to the same mode. That's why it looks the same. So, text 32 by 24, mode 0. So, pay more close attention. But now we can change and we'll go into different video modes. Sure, no problem. Bing, save. Close this off. Build again. Build again. And now, boom. We're now seeing that we're now typing in 40 columns instead of 32. And you can see the difference. So now we switch text modes. This is kind of how you put these things together. There are other interesting things we may have seen, for example. There's this whole video /TMS9918.h. What's inside of that? Well, let's take a look at that. Let's take and go to our little bookmark here, and let's go into 99x8.h. And in fact, let's just take this off. Ooh, look at that. Include in video. Let's open that up. Boom, boom. Okay. We have VDP routines all over the place in here. Let's see. We got video modes. We have VDP, and we have different ways that we can set the video modes, even in a more direct manner than what we were doing. So VDP set mode, here's an equivalent, even simpler than what we did. This might be useful. Let's take a look. So we will go back to our workspace here in hello. Edit hello.c here. Let's simplify this a bit. We don't need this variable anymore. Bam. We don't need this anymore. And we don't need that anymore. Okay, fine. That's all, that's gone. If we know that we're going to keep this on this platform, we can simplify things, and that's an interesting thing. Programming is full of assumptions, and they can help simplify what you're doing. So let's take and look again. VDP set mode. And it takes an integer, which is the mode you want to set. Of course, it needs to be semicolon right there. We replace that with that. And we do much the same thing. So, boom, save. Now let's build it again, see what happens. Okay, cool, that built. Much the same thing happened here. Well, let's take and change that video mode again. Okay. Go to 1. OS. Build again. And now we're in mode 1, and we're seeing some interesting little side effects here of how mode 1 support actually works here, which, okay, means you got to use it a little bit differently, but now we're in mode 1, and so on, and so on, and so on. But there are all sorts of things. Well, let's take and let's go back to mode 0 here, the text mode, and see if we can change the background color, because mode 0 allows you to change the background color. That's easy enough. VDP set care, VP V-read, so you can read and write to the VDP, VFill, fill things with characters, set individual registers, which we know we can do that. Okay, great. But this looks interesting. VDP color, foreground and background and border. Maybe that's useful. Let's see here. Let's bring that out. Copy that out. Let's try something here. VDP, put a semicolon at the end there. So foreground, let's say use foreground of, we'll use foreground of 4. We use background, foreground looks white, background of 4, you know, and border also 4. Well, since we're in mode 0, actually, the border sets all the background elements here. But, you know, whatever. Bam. Okay, save that. Let's see what happens here. Okay, that built well. Let's see how this looks. Boom. And now we've changed the background here. Great. Okay. Maybe we can keep modifying things and seeing how it works here. Let's change that to 7. Each of those, and we'll see what this does. And so on, and so on, and so on. You can start to see how this all fits together. So you can start modifying and messing around and seeing what's possible. Well, what is VDP color here? Well, let's do a little search for it. We've got the documentation up here. So let's see if we can do classic 9918. Okay. Got this here. VDP screen modes. Mode. Okay. Okay. Do we not have? Maybe VDP. Anything else? More stuff that we can take and peel through. But you can keep adding on and doing certain things. And this is essentially how you figure out what is actually possible. You can start fiddling around. You can basically just build little bits and pieces of things. And I want to use the last moment of this particular video to show you that there actually is an examples folder, which has all sorts of stuff sitting in here. Particularly, you have folders called MSX and Nabu that can also work on Coleco and on other systems here. And when you use build.sh, you can actually have the system build examples for those. All sorts of different things. Examples. And see what those examples actually do. Well, let's take a look at one of them, for example. Pardon the pun. Open a terminal window here. Can we do the same thing that we've done before? And do that? Undefined symbol, I2F. Well, let's have a little look at this little, we have a make file here. Let's take a look at it. We have a few little things that get added here. Some libraries and things that get added. I see one that might be of use here, the LM, which is the math library, which might help us here. we can add that in. See if that helps. Okay. Star randomize. Okay. Look at that again. lib3d. Okay. I guess it wants that too. Okay. Well, there it is. We needed all of those libraries. Okay. Now we have a. Excuse me. Let me do that again. I'll just run it from here. Well, that's certainly interesting, if a little strange, but you know, there we go. You can see the different examples and how they work and how they translate to our given little platforms. Maybe another one. EX2. Where's EX2 ROM? Oh, I call it also. And so you can see all these little examples that give you insights on how to take and program the various parts of the Z88DK ROM. And actually, I lied. I want to do one more thing to provide, because I did promise that I would point you in the right direction for books. See what our video runtime is right now. Oh, wow, 41 minutes. Okay, I'll end this at the 45-minute mark. Nice and simple. There are lots of good books that you can use to help you on your journey to learning C. One that I absolutely recommend, and you can check this out at the Internet Archive in their library, is the C Programming Language, 2nd edition, from Brian Kernighan. This is the canonical book explaining how the C language works, and it was updated. During the late 1980s to take into account the ANSI-C programming language, which maps very nicely onto Z88DK. It gives you the points and the concepts of the language and how certain things work. I highly recommend picking up a copy if you can find one in a used bookstore, or checking it out from the library here, etc. Another good book is Practical C Programming, aka the Cow Book. And this is by Steve Oweline. These are not as speculation nutty. You can get these for a decent price, as you can see, and there are versions of it. Oh, come on. Why are you sticking? Wow. It's like, I don't want you to go. Okay, fine. Now it's you then. I'll ask you to do it again. So, Practical C Programming. We have a PDF of that right here. And everything, which takes you through the ins and outs of the language in a very clear and very concise way. I recommend these two books pretty much above everything else for someone starting out and understanding why C is practical, why C is good to use for something like this. So I'm going to go ahead and end the video here. I hope you guys have enjoyed this. I will be continuing our little journey here. The next video is essentially going to start building on the fundamentals of C and how the bits and pieces are put together. So until next time, guys, have fun.